Hi guys, welcome to Tech Geek. So today we are back with a daily Leetcode challenge. That's Candy, a Leetcode hard question, hard 135. So this was a question that requires some greedy approach. That's why it's considered as hard. If in case you do not get to know how the problem is going on, have your minds clear with the greedy and deeply because mostly questions asked and the hard ones are related to it. If you still don't know what is a greedy approach, go check out some videos on the approach and then only try this question. Before beginning, I'd like to request you all to please like, share, and subscribe to my channel. In case of any queries, do let me know in the comments. Now, let's look at the solution. So, the question says there are n children standing in a line. Each child is assigned a rating given in the array ratings. Now, you are given candies to these children subjected to the following requirements. Now we have these two constraints that must be followed. Each child must have at least one candy, and a child with higher rating gets more candies than its neighbor. So we are concerned about the neighbors here. Return the minimum number of candies you need to have to distribute the candies to the children. So you need to find the minimum. So you have to minimize in greedy approach we use two to three things. So here what we need to minimize is the number of candies. Okay, and we know n number of people are there. Constraint that if you're talking about neighbors, so obviously one person will have two neighbors. So the one with a higher rating should have a greater number of candy as compared to the neighbors. So if we talk about 0 and 1, so smaller one is 0, so it should have less and at least 1 is required, so 1 should be here. If we talk about its neighbor 2 and 1, now both of them are greater and this is 1 and all of both of them should have greater than this. As we need to minimize it, so we'll choose the minimum value that they can have. They can have 2 to n, how many they can have. So that's what, so total is 5. Let's see how we can approach this problem now. These are two different problems. First we'll check with this approach and then this. Okay. So what we'll do, we'll take another array with the same size that will store the number of candies. And initially let's take each one of it gets one candy, as it is said that we require at least one. Okay. Now what we'll do, we'll traverse the array from I equals to 1. So we'll skip the first, we'll check here and we'll compare if the rating of I is greater than ratings of I minus 1. Is this greater than I minus 1? No. Come to the next one. Is this greater than I minus 1? Yes. So what we'll do, for this I, that's I equals to 2, make the rating as 1 plus the initial. So it should be greater than 1 by its neighbor because it was higher. Now we have this. Now total candies which are required, let's take that as sum, and we'll initially give it the value of this last element. Okay, so this last element was 2. Now again we'll traverse but in backward direction. We'll begin from length minus 2, that's here. Now we'll compare if this I, ratings of I, is greater than I plus 1. Is it? No. Come here. Is this greater? Yes. What we'll do, for this value, that's I goes to 0, you will check if the rating of I is greater than I plus 1. Yes. Now we'll store the maximum of this and this plus 1. So we'll store the maximum of a candies of I or candies of I minus I plus 1 plus 1. So this is 1, this is 1. 1 plus 1, 2. So obviously maximum is 2. So this is the distribution that's required. Now coming to the sum, what we will do, we'll add the sum. Initially it was 2, then 1 plus So it's simple, 2 times traversal of the array. One in this direction and second in this direction. Let's check this in a longer array, that's the fifth one. Okay, so that this approach gets clear to you how we are minimizing it. Okay, okay, so initially we have 5 elements and we'll make all 5 elements as value 1. So that's what we are required to do. Okay, so let's do the same. 1 1 1 1 and 1. Now we'll traverse from I equals to 1 and compare these two. Okay, this is the one and this is the one. Again we'll compare. Ratings of I is greater than I minus 1. Yes. So make this as 1 plus the earlier one. So this becomes 2. Come to 2. Is it greater? No. Come to 0. Is it greater? No. Yeah, 2 is greater than 0. Yes. So this will again become 2. Now we have the value of sum. Sum will have the last element 2. Okay. Now what we'll do, we'll traverse from length minus 2 and check from here till here, right? I plus 1. So is 0 greater than I plus 1? No. Is 2 greater? Yes. 2 is greater. So for this value, we'll take 1 or 1 plus 1. That's 2. So obviously 2 is maximum. Again check. Is 3? Yeah, okay. Is 3 greater than this? Yes, 3 is greater. So what we'll do, either take 2 or 2 plus 1, 3. So 3 should come here. Is 1 greater? No, 1 is not greater. So the number of candies required is now 2 plus 1 plus 1. Okay, let me write this. Plus 1 plus 2 plus 3 and plus 1. So we have 4, 5, 6, 7, 8, 9. So 9 candies are required. Okay. So this is the result of our solution. You can see we are traversing it 2 times, that is 2 into order of n. So initially we can say it's order of n. Okay. Now let's look at the solution that's given to us. Okay. I request you all not to go with the solution first. Check the approach, try it on your own. If you can do it, that's really good, because that's what you need to learn and not just the copy pasting of the code. Because even in the interviews, you'd be asked to solve on your own. Okay, so we took an array candies, filled it with 1. The first traversal, that's checking from 1 to n minus 1, and if the ratings of I is greater than I minus 1, so we'll make that as I minus 1 plus of 1. Took the last element as sum, traversed again in the opposite direction, length minus 2. If ratings of I is greater, then take the maximum of candies of I or candies of I plus 1 plus 1. In that case, what we are doing after checking this, we are adding it into the sum, because sum is the only thing that's required. So we'll put the sum as the output. So as you guys can see, we are using order of n here and order of n traversal. So obviously 2 times order of n is actually order of n. So that's what our time complexity is. So if in case there was any doubt with the solution, do let me know. Anything you want to know, any particular solution, any, you can say, interview experience or anything, then do let me know. I'll be there to help you out. Thank you so much, guys.